This video demonstrates a model railroad that is controlled by an Arduino microcontroller. The railroad track forms a Y with one leg being referred to as the main line and the other leg referred to as the yard, which is like a parking lot for railroad cars. A black mechanical switch at the Y determines if the engine will travel into the yard or on the main line. This project requires a 12-volt DC power supply to send power through the tracks and into the engine, relays to control the voltage going into the tracks and to control the mechanical yard switch, an Arduino microcontroller to operate the relays, and a computer to write the controlling software that gets uploaded to the Arduino. At this point, the laptop shown is not doing anything except providing power to the Arduino. The program does not take any inputs. It is entirely based on time, which is calculated internally. The train drives forward for X milliseconds, stops for Y milliseconds, then reverses for X milliseconds, and stops for Y milliseconds. At that point, the yard switch gets changed and the program for the train runs again. The relay module contains 4 switches that are operated by the Arduino. 4 lights indicate if those switches are on or off. 2 of them connect the track rails to the positive or negative terminals of the 12-volt power supply. If both relays are off, then the train does not move. If one is on, then the train will move forward. If the other one is on, then the train will move in reverse. And if both relays are on, then the train does nothing. The other 2 relays are used to operate the mechanical yard switch. One relay determines if the track will be switched toward the yard or main line. Nothing will happen to the yard switch until power is engaged with the 4th relay. The 4th relay engages power to the yard switch and is programmed to be momentary, which means that it briefly gives power for 1 second and then shuts off. This is because it is not good to send continuous power to the solenoid that is in the yard switch, or else it will burn out. The next step for this project is to add in sensors which detect when the train has reached a certain point on the track and then cause it to stop and reverse.